Hey guys, in this lesson we would understand how to calculate limits from the graphs. First of all, we need to know what are limits exactly in math. Limits in layman terms we can say is the destination or the zenith point you are approaching. So when it comes to math problems, where is the particular function or where is a particular equation reaching and what is that end point for that x value is called the limit. Let's understand it with an example. If you're given this kind of a graph, let's say we call this graph as fx and we want to find out what is limit of x approaching -2 for fx. That means what is the value of y when x approaches -2. So whenever we have to find the value of y, because we all know fx means y. So if we want to find out the value of y for x approaches to -2, we need to walk towards -2 on the given graph. So we are walking towards -2 on the given graph. And the way we have to walk is we have to walk from left to right on the interval. And we also have to walk from right to left towards -2. When we are walking from left to right, we can write it as limit x approaches to -2 from the left side. So the small negative sign on top means we are approaching -2 from the left side. So what is the value of y when we are approaching -2 from the left side is, when we read it on the axis, it is equal to 0. Next we have to check is when we walk on the graph from right to left towards -2, and we notice that can be written as limit x approaches to -2 positive. Positive means we are walking from right to left. We want to find out what is the y value when we are approaching -2 from right to left. And we again notice that we are reaching y equal to 0. Now always remember to write down the final limit or to write down the final destination of the function, because here we are talking in terms of a function. So we want to find out what is the destination of this function when x is approaching -2, and that is going to be equal to 0. Now whenever you have to give an answer for the limit for a particular x value where fx is approaching, you always need to make sure that you're finding the limit from the left side as well as the limit from the right side. If limit from the left side is equal to limit from the right side, then we finally say that the limit exists. And the answer of that limit is same as the values that you have got from the left as well as the right side. Let's take up another example on the same graph, and let's say if we want to find out what is the limit when x approaches to 2 for this function fx. Again, we follow the same procedure. We are going to be moving towards x approaches to 2 on the graph. We notice when we are approaching 2 from the left side, the y value that we are approaching is approximately 2. So we can write it as limit x approaches to 2 from the left side, fx is equal to 2. Now if we are walking on the same function fx and we are approaching 2 from the right side, we notice this part of the graph is finished on the right side of x equal to 2, but we have this second piece of the graph that has a value or that is continuous after x equal to 2. So when we have to approach x equal to 2 from the right side, then we have to walk on this path. And if we read this value, we get to see that we are approaching -1. This can be written as limit x approaches to 2 from the right side of fx is -1. Since limit x approaches to 2 from the left side is not equal to limit x approaches to 2 from the right side, we would say limit does not exist. And if limit does not exist, there is no solution. So the final solution is going to be limit for x approaches to 2 fx is does not exist. We can write it as DNE. Okay, let's say now if we were asked to find out what is the value of f of 2, this is not a limit, it's just calculating the value or determining the value from the graph of f of 2. In this case, we are asked to find out fx when x is equal to 2. So some students, they ask the problem like, because x is equal to 2 is two numbers. So we notice when x is equal to 2, you see a point here and you see a point here. So out of these 2 points, which point is the right answer? For that, we would look at the solid circle. Now this is a solid circle, this is a hollow circle. So when x is equal to 2, the fx is supposed to be 2. Reason being is, when x is equal to 2, at fx negative 1, it's a hollow circle. Hollow circle means the value at x equal to 2 does not exist on this part of the graph. It starts after x equal to 2. Solid circle means the value of x equal to exists on this piece of the graph starting from negative infinity up to x equal to 2, including x equal to 2. Therefore, the solution is f of 2 is equal to 2. Therefore, we can conclude if we want to find out the limit for a particular point on the given function, we have to walk on the graph towards that x value from both left and the right sides. If both left and the right sides have the same value, the limit exists on that value. If both left and the right side does not have the same value, the limit does not exist at that point. And for getting the f of a particular x value, we follow the same procedure as we have learned in previous grades. All we have to do is just look at the x value and read the fx, keeping in mind that the solid circle is the one that we will be reading instead of the hollow circle. Sometimes we're also asked a question, does limit only exist if we have a value of function at that x value or not? Let's understand that with an example. So in this particular graph, if you're asked to find out what is the limit of fx when x approaches 4. To find that out, what we have to do is we have to walk on the graph to get the limit for x approaches to 4 from the left side, and that would give us the fx value as, let's read it as approximately 3. Then we have to walk on the graph from the right side, that is limit x approaches to 4 with a positive sign. When we read the fx value, we notice we are also approaching 3. Since limit x approaches to 4 from the left side is equal to limit for x approaching to 4 from the right side, and that is equal to 3. So the answer for this is 3. Then we notice here that f of 4 is not equal to 3 because it's a hollow circle. Even though f of 4 is not equal to 3, we still have a solution for the limit. Reason being is the solution for limit does not depend upon whether we have a value of fx at that x value or not, but it depends upon where are we approaching, where are we reaching. So if we are reaching the same point, limit exists at that point, no matter if we have a solution for that particular point or not.